So in this tutorial we are going to create our face recognition software. So we are going to create an avatar that is going to be able to look at the video and determine what face expression the person is having. You will be able to do this over your webcam or maybe load an already existing file. This is an extremely exciting project, and we will do this one in a bit different way than we have done our other projects. So if this sounds interesting to you, let's get started. So how is our development road going to look like? First of all, we are going to go through the theory and preparation. We are going to give a little bit of insight what deep neural networks are, what libraries we are going to use, how we are going to prepare the environment where you can download your dataset, and so on and so forth to prepare for the actual development. Then we are going to create and train our model. You will go through how to develop the theory that we have just mentioned into our model, how we're going to train it, what parameters we need, how we're going to create those layers. We are also going to explain what convolutional networks are, what deep neural networks are for, and how they can be used for image recognition. Then we are going to create the GUI. We are going to create a Python GUI using TkInter. We are going, as you have already seen, to live stream the video and our predictions, and also our avatar to our application. So if you're interested, let's get into coding. Okay, let's get started. This project is going to be a bit more complex than the other ones, since it's going to involve a lot of machine learning and deep neural networks. So I'm going to try to explain it from a light overview, so you can understand the code, what's going on, so that you could build something like this on your own. But I'm not going to go too deep into the mathematics and the theory behind it, since this is extremely complex and explaining all those little things behind it would take much longer than the entire course here. So, but you will be able to understand all those concepts and apply them into real life projects. Okay, let's get started. So I have a blank project open here. So like always, let us create a source folder first. And in this folder, we are going to have our application, and we are going to have our training data and our training Python file. So let's do those. So let's create a train.py, and let's create a emoji.py file, and let's create a data folder in which we are going to store all our data. But before we start, let us explain what we are actually creating and what components we need for it. Here I have my drawing board open, and as I have already mentioned, we are going to create a neural network. Why? Because neural networks are great for this purpose, for image classification, patterns classification, and generally classifying objects and extracting certain features out of them. So let us explain what is a deep neural network. A deep neural network is a normal neural network that has a certain level of complexity. So this means that it has more than 2 layers. So what do I mean by that? So let us examine this here. We have some information, some data that goes into our network. So this is the entry point. Then, so this is our entry layer, so to say. Then we have a hidden layer inside of that consists of a certain number of neurons that we are going to define later. And now we have connections all over here and all over here and all over here. So I didn't draw this too nice, but as you can see, everything is connected with everything. This is one layer. If we have more than one, so let's say we have 2 here, which are again all interconnected, like that. Then we have two hidden layers, which would make it a deep neural network. And then we have some output, which is this here, which will output our results. So data goes in here. We have a hidden layer that trains itself, that based on the inputs and the restrictions and the rules we give it, figures out some type of mapping and outputs data here. So a neural network in general is a technology that is built to simulate the activity of the human brain. As you can hear, we have neurons, we have connections. It kind of reminds how the human brain works. So why is this technique extremely good for finding patterns, recognizing data, and finding certain features in our input data? Because we can find features, certain features in our input data. So let's say we have an image and we want to classify only images that contain kids, for example. And this is a feature. So we could, while training the data, every kid has a certain feature. So a kid is smaller than an adult, it probably has a certain type of hair, certain size of shoes, and so on. And all those little features are great for specifying or for categorizing our input data. So the alternative to this would be to write those algorithms manually and really search, for example, the height of the person and specify, okay, if the height is lower, then the probability that it's a kid is like that. And if it has a t-shirt where Mickey Mouse is on the t-shirt, then the probability again increases, and so on. And we would need to create all those rules manually. And that's where neural networks are great, because while training our data set, we are going to create those feature hierarchies or feature layers that are great at examining and finding those specific things onto our dataset and classifying them. So what do those layers actually do? Each layer performs specific types of sorting and ordering in a process that can be referred to as feature hierarchy. One of the key uses of these neural networks is dealing with unlabeled or unstructured data because of that. So this is just a simple overview of how this works, and you will see all those layers that we have just mentioned here, how we actually implement them in code. There are certain mathematical operations that go into this, and this is where it actually becomes really hard. So each of those layers, as we have mentioned, is going to do something. It's going to sort our data, it's going to extract some values based on some mathematical formulas, and that's where the entire complexity of it gets to, creating those formulas, creating those models, and thinking of ways how to process the data. So this is where the hard thing is. But implementing that, if you already know what we want to do, is really quite easy, and you will see this right now. So let's return to our code here. We have a little bit explained what a neural network is. So in this case, we are going to create a deep convolutional neural network. So there is one more thing to explain here, what convolution actually means. It is a mathematical operation on two functions that produces a third function. So this is what we have already mentioned. So we get some shape that goes in, two values are somehow multiplied, some operation is used on them, and the third value is produced. I'm pretty sure most of you are familiar or heard the term TensorFlow, which is a library in Python that provides a lot of features to work with those machine learning algorithms. So we can even make this easier by using Keras, which is a high-level interface on top of TensorFlow that makes deep learning much easier, since it's going to provide us all that functionality through some functions and simple APIs, which we can always search in the documentation, and it's just going to make our life a lot easier. So let's start. The first thing we need to do is import a few packages. I'm going to paste those packages right here. Throughout this project, I'm going to copy and paste more code, since it's much easier if I paste the block here and then I explain line by line what it is doing instead of typing it out, since a lot of those operations can become quite complex and they're quite standardized and can be always referred to in the documentation. So here we have our layers. There are, for example, a dense, dropout, flatten layer. There is a convolutional 2D layer. Then there is Adam, an optimizer. Then there is max pooling 2D. And there is also for pre-processing image data generator. I will explain what all those layers and the image generator do. So the next thing is, since we want to train our data, to train our model, then we want to save the model. And then inside of our application, we want to load the model and work with it. So I made a mistake here. This should go into the train dataset, train file. So in order to get our data, head to the following website, go to kaggle.com. You could use some other dataset. I'm using the FER 2013 images, where we have exactly 958 files or images from an angry person, from a disgusted, fear, happy, neutral, sad, and surprise. So for example, if you open this, you will see there are a bunch of images, black and white images that represent people experiencing a certain facial expression. So you could use something else, but I'm just going to download this one. After it has downloaded, we can extract the files and move it to our desired directory. I have moved the data to the data folder here. Under test, you can see there are our images, and you can see there is also the images under train. And I have also created a folder examples where I will upload recordings of myself to test the application. You of course can use this live on your webcam, or you can use a recording. I will explain you how you can do that. Okay, the next step is to actually work with the data. So I have created a train directory and a validate directory, so which is under data train and data test. So now we need to create an image data generator, which is going to generate a data set from the image files in our directory on a scale from 1 to 255, since we define our images in pixels, which is nothing else than just an array consisting of a value between 1 and 255. We are creating the same thing for our training and validation data. And then we are going to create our generator from the data we have just imported here. There's a few things we can specify here. A target size of our data, which is going to be 48 by 48 pixels. Then we can specify a batch size. The batch size is a term used in machine learning and refers to the number of training examples utilized in one iteration. Then we can specify the color mode. We are going to use grayscaling. So this is for gray scaled images and black and white images. And the class mode, which is categorical, since we have categories of angry, disgusted, fearful, and so on expressions. Now let us create our model and prepare it for our training. So I'm going to paste in a bunch of code here. which looks pretty strange here, but I'm going to explain it line by line what everything here means. So here we are initializing a new variable, and we are initializing a sequential model. So by using Keras, we have two options here. We can use a sequential and functional one. The sequential API allows you to create models layer by layer, which is the preferred way for most problems. But it is limited in that it does not allow you to create models that share layers or have multiple inputs or outputs. Alternatively, the functional API allows you to create models that have a lot more flexibility, as you can easily define models where layers connect to more than just the previous and next layer. So this means you can connect layers to literally any other layer, which is quite powerful, as you can imagine. But as a result, it is much more complex and a lot more things become possible. But for our case here, this will be too complex and unnecessary. So we are going to initialize a sequential model here. Now we come to the interesting part. We can add layers here by just specifying add. So we have added a lot of layers here. So remember, this is the thing that we have shown in the graph earlier. We have said that we have certain layers here. And if you have more than 2 layers, then it's a deep neural network. And those are exactly the layers that we are specifying here. And since we are creating a convolutional neural network, which we have mentioned earlier in this video, but let us explain one more time what this exactly is. It is a special type of neural network that is very effectively used for image recognition and classification. They are highly proficient in areas like identification of objects, faces, traffic signs. They are used in self-driving cars, robots, and so on. A convolution is the simple application of a filter to an input that results in an activation. So there is some certain input and there are certain thresholds, and when that input meets those thresholds, then there is an activation, which you can see here, for example. Repeated application of the same filter to an input results in a map of activations, which is also called a feature map. So if there is a certain type of input that goes in and that input repeats itself in a certain way, then we can already see that there is a map forming, a feature map also called. That's indicating the locations and strengths of a detected feature in an input. For example, in our case, that's going to be a bunch of images. So as you can see, the strength of this is that we can access that we can have a lot of features defining certain categories and types, which we can then use to train our model on, instead of having all those features typed in a manual approach. So let us explain what each of those layers does here. So the first layer is a 2D convolutional layer. So this layer creates a convolutional kernel that is convolved with the layer input to produce a tensor of outputs. So we provide the input shape here, which is 32. We specify the height and width of the convolutional network, which is 3 by 3, and the input sphere represents our pictures, which are 48 by 48, and they are also grayscaled images. And here we specify our activation. This RELY stands for rectifier, which is an activation function used in neural networks. So it is one of the most common used activation functions. There is also the math behind it, which you can look up, but this is quite complex and we are not going really to cover it any deeper. But for your knowledge, in most cases you're going to use Arial U, but you can of course see the math that stands behind it. So here we are again creating a convolutional 2D network. So the max pooling 2D is going to downsample our data. You can always refer to the documentation here under keras.io. But what this means is downsampling means training on a disproportionately low subset of the class examples. So the reversed one would be upweighting, which would mean adding an example weight to the downsampled class equal to the factor by which you downsample it. So we are downsampling it to include less data, a smaller subset of the data. Then we are using dropout. The dropout layer randomly sets input units to 0 with the frequency rate at each step during the training time, which helps to prevent overfitting. So overfitting means that a model that has learned the noise instead of the signal that is considered to be the required signal for learning. So you always get certain signals and you always get certain noise. You don't need the noise. Overfitting means that you take the noise, so to say, too seriously and train the model more on the noise than the actual data that you need. So that's what the dropout layer is for, to reduce overfitting. Then we have again the same layers here. Again, dropout. Then we have a flatten layer, which we need to flatten it before we turn all those neurons that we have, that we are going to have here, into those 7 neurons here. So I'm going to explain this in a second, but let us first explain the dense layer. The dense layer is a hidden layer which is going to contain 1024 neurons. So this is the number of neurons or units that this hidden layer is going to contain. And then we again have a hidden layer here, which only contains 7. So this layer has to contain the exact number of possibilities that we can have. Since in our data here, we have angry, disgust, fear, happy, neutral, sad, and surprise, which are 7 categories that we can have. So we specify, we have to convert all those 1024 units into those 7 here. So this is what we have drawn here. So let's imagine here we have a lot more neurons going in here, but we have only 3 categories that we need to output, and we need to convert all those neurons into 3 here. So as you can see, this can become quite complex. The programming side of it is not that complex. You have to just specify a few types like the activation, your pool sizes, and so on. But the complex part is actually coming up with what layers where to use. For example, this is a standard approach that is well documented and used in a lot of papers to train for exactly this purpose here. So I didn't come up with this on the top of my head, but rather used a paper and some forums to reference on people's results. So people claim that they got really nice results by creating a layer like that. So this is going to be the major part of machine learning as it is. So you are going to be able to see a lot of, you're going to be able to learn all those things quite easily and learn what functions stand for what. But the problem of it, the complexity of it, goes into designing those networks for certain purposes that are not documented yet. Now let us actually compile our model, train and save the model. So what we are going to do here is compile our model. Then we are going to fit it to start training it, and then we are going to save the weights. So this is our model. We are going to train it, calculate the weights and save it as here. So in order to compile, we have to specify certain things here. So we can specify a loss, which is the degree of error. The models try to minimize loss, but they don't try to maximize accuracy. So we are using the optimizer atom here, which is the most complex part to say. It is quite mathematical and gets quite complex under the hood. But it is a very standard optimizer that is used for creating those models. So the categorical cross entropy is also the most common one, which is just the type, the metric, how we are specifying our losses. Since we need to specify the metric that we want to track, and we want to track our accuracy, we are going to specify accuracy as our metric. Okay, now it's time to train our model. So we can specify certain things here, like the train generator, the validation generator that we have specified earlier, the epochs or number of iterations we want to do it, and steps per epoch. Since our batch size is 64, we are going to divide it by 64, and we are using this divider here to round up to the next whole number. And then after this is finished, we can just save our weights here, and we are going to save it in the source folder. So now, in order to run this, open Anaconda or your terminal here. We're going to navigate to source, and now we can start training it. In order to do that, just I need to save this before, just type in python train.py. And if everything works correctly, this should start training at some point. Okay, great. It started. So we are at epoch 1 and our model is training. So as you can see, this is going to take some time to complete. So you can always specify less epochs to do it faster. 50 is a quite high number. You probably don't need that much, but it's going to take some time. I also didn't tell you what modules you need to install here. So you need to install TensorFlow, NumPy, CV2, which is OpenCV, and Keras. I'm going to stop this and just do that here. So you're going to run pip install OpenCV Python. I have already satisfied the dependency, so there's nothing going to happen. You will need to install NumPy. You will also need to install TensorFlow, and you will need to install the version 2.2 or higher. I'm using 2.2 here. Requirement already satisfied. So this is also important. You need 2.2 or higher, and we're going to install pip install Keras. So after you have done this, everything should be working quite fine and the model should be training. So I'm going to let my model train now, and let's continue in the next video. The training has finished and our model is generated now. So the next thing is to go to our emoji.py and actually load the model and work with it. But before we do that, there is one more thing we need to do, which is quite fun. We need to have already some emojis. So we're going to create a folder called Emojis, and there we are going to generate some emojis. Go to this website here, which is called getavatars.com, where you can actually create an emoji. So I have created certain ones for being sad and for being happy, for being disgusted, and so on. So you can play with this a little bit and create the emojis you would like to have. So this is basically self-explanatory or quite funny. So what I ended up creating is this here, which is quite funny, for angry, disgusted, fearful, happy, neutral, sad, and surprised. As you can see, there are certain musters that you need to follow for creating those expressions. So for example, someone who is angry has his eyebrows like that, open eyes, mostly the mouth is also open. So you can play a little bit with that and create the emojis you would like. For example, this one is also going to be yellow when he's really angry. So I had a lot of fun creating those avatars. So now let's paste in the code we need. Okay, this is a lot of code pasted in here, but there is really nothing special. I recreated the model here. So since in the training file, we have only saved the weights and not the entire model. Here I am also loading the weights and I'm using the same model. So this is just copy pasting. We could also export the emotion model here and import it inside of our emoji.py. Would be exactly the same, and just load the weights. Here we have the same imports again, pyl for image, since we are going to create images using TkInter. I have also imported TkInter, and I have also imported threading for multi-threading. So all of this is already provided. Threading is also provided with Python, and one more thing is pil that we are using to import images, which comes from ImageMagick. I have installed ImageMagick on other projects that we have done, but let us do that quickly. So in order to download ImageMagick, just head to ImageMagick for Python, go into downloads, go under Windows, since I'm on Windows here, download the first release here. After you have downloaded the executable, just running, it's just following, click next and finish. I accept the agreement, next, and also check to install ffmpeg and finish this. I have already installed the program, so I'm not going to do it twice here. After you have done that, you should be set up with all the requirements you need. This here is self-explanatory. We have already explained what we have done here. So let us continue. Okay, let's paste in the next part of the code. Okay, we are now creating a dictionary here of all the emotions that we can have, which are angry, disgusted, fearful, happy, neutral, and so on. Now we need to import the PNGs that are here inside of our emojis folder. So in order to do that, we are generating the current path here. So in order to generate the current path, we are using the OS library, path directory name, and we are referencing the absolute path of the file that we are running. So in this case, we are running emoji.py, and this is in the same folder. So we just need to navigate from the current path into emojis and pick the corresponding expression. So plus emoji angry, plus emoji is disgusted, and so on. And be really sure that you are using the correct path here, because if you're not, you're going to run into some problems there. Now we're defining some variables, which you will see what they are used for later. Let's paste in the code for that. I'm going to start with the main function here. So let's paste it in. We have already explained how this here works. If we are running the emoji.py file, this is going to be our main file. So this is always nice to have if you're having multiple scripts. And again, we are using TkInter here. We are specifying a frame number, since we are going to later read through our file, and we are going to increment frame by frame. So this is our global variable here. Here we are initializing our root frame for TkInter. Here we're just creating labels, main and main2, which are going to be our labels that are going to contain our images or our video. Here we have a third label, which is going to be for quitting. And here we are just packing our labels here and placing them in our location. So nothing too fancy here. Here we have specified a title, and here we have specified geometry 1400 by 900. Here is our exit button. We have placed it to be on the bottom. And now we are going to have two functions. One function is going to show the subject, and the other function is going to show the avatar. But we are going to use threading here because the main loop is blocking. Since when we get to the main loop, that's everything that's going to run. We are not going to be able to run anything else. If there is a program that's taking too long, for example, it's going to block our main GUI, main Python GUI. We have experienced that by building other projects. So here we are actually going to provide a solution for that, since we are going to have the show subject function, which is going to run indefinitely if you use our camera, and our show avatar, which is going also to run indefinitely. We are going to need to start those in a new thread. And we do this by calling threading, thread, specifying a target, which is our function here, and then we just start the thread here. So fine, so good. Let us define the show subject and show avatar functions as next. This is going to be quite a longer function, so let's paste it in. Okay, this is our show subject function. Let's go this line by line. The first one is going to open our video. In this case, I'm going to have some saved video, which I'm going to be using. Here I'm just specifying the path to that video. If you're going to be using your webcam live, then you should just give a 0 here. That's going to specify that you're going to use your first internal camera. So if you have a webcam, you can use this. If you don't have a webcam, or maybe have some prepared footage, just give the path to the footage that you need. And now, this is a test. If the camera is not opened, we will print out can't find the camera. Now, here we are using the frame number, which is a global variable. And we need to specify global here before using it, so that we are not creating any local variable frame number. Otherwise, it would give us an error saying that we are referencing a variable that is not defined yet. The next thing we need to do is definitely get the length of the frames. So we need to get the maximum number of frames so that we know when we can exit. This cap prop frame count is going to provide us that information. And we are going to increase the frame number with every calling of the function. And if the frame number exceeds length, we are going to exit. The exit here is a built-in Python function that we can use, which basically represents sys.exit. Now we set the next frame that we should be reading to the one that we have incremented to, and then we read the frame. So remember, this is our file here. In order to read frame by frame, we are calling the read function, which is going to return a flag and the frame. The frame is actually the frame, which is an array that we are going to get back. And the flag one is going to specify if we have actually read something or not. Then we are going to resize it to a certain size, which is going to be 600 by 500. After which we are going to use a bounding box. The bounding box is going to represent a box around the face of the person. So in order to do that, we would actually need to develop a new algorithm, a new model that actually can detect those boxes. But OpenCV comes with something already prepared here, which is Cascade frontal face defaults.xml. So since I'm using Anaconda here, I'm going to show you how you can find this. So let's copy this and go into your users, Anaconda, library, and side packages. This is under CV2. Okay, here we have CV2. I think then it's under data. Now go under data. And here you have those predefined XML documents. So in this case, we're going to use Cascade frontal face default.xml, which is going to detect our frontal face. Now we're going to convert our image to gray. We can do this by calling CV2 CTV color, and we are going to convert our frame 1 with the function color BGR to gray, which is quite self-explanatory what it does. Why do we generally do that in machine learning? There is a reason for that, because most classifications and processes can already be done by using grayscaled images, but the huge advantage that we receive here is the memory usage, so the bandwidth, the data that we need to put through. Since those images are going to be easier to process, since they contain less data, we can fasten up our processing times. So now we are going to detect the face here. Now we are going to find the X, Y, W, and H coordinates in the num face, and we are going to create a rectangle of those. After that, we are going to crop our image. We are going to crop it of the resize frame that we have generated here to 88 by 88. Then we are going to predict the emotion using our emotional model from here. And we are going to predict the emotion based on the cropped image. So we have refined the image a little bit here, which is a standard way of doing it. This is basically copy paste from the official documentation. We didn't need to do it in a that complex way. We could just have X, Y, W, and H and just crop it right here and have the image already used. But this is a more elegant way and more efficient way to do it, and then afterwards also resize the image to a 48 by 48 size. Since remember that we trained our model on images of the size 48 by 48, so that's what we need to do here in order to use it for our prediction. Now we are going to get the index out of it. Remember we had here like 7 outputs, and now we're going to get that output, which we have prepared here in our dictionary. Now we are going to check if flag 1 is none. We're going to print an error, since this would mean that we somehow didn't manage to read the frame. And there is one more thing that we need to do, which is update our main window. So in order to do that, we're going to get our frame. We are again going to convert our picture to RGB. We are going to create an image. Always remember that the images that we are working here with are arrays, and those arrays contain values between 0 and 255. So in order to generate an image from that, we can call image here from Peel, which we have installed with ImageMagick, and from the array generate an image. Now we are going to create an image TK that we can use for our TK label. And then we are just going to set, remember here, this is our label. We're just going to set the image TK, which is value from our label here. And we're going to set it to our image that we have generated here. Now we have configured the image to be this, and we are updating our root. This is important since we are running this in a different thread. We need to update our main thread where our TkInter graphical user face is running from here. And now we are going to call our function again. After 10 milliseconds, we are going to call our function again here. So what this after does is also a way to use TkInter to get around this problem with the blocking. Since our main loop is going to be blocking, it's a while loop that never ends. We can run this after here. For example, let's say we would run this before the main loop, then the entire program would wait for the specified amount of time here. So in this case, 10 milliseconds. And after that time is passed, after the time passes, the function would be called, even though that our main loop is running. So this is what after is used for. And in the case that we type in something with our key or press Q, we are going to exit as well. There's just one thing missing, and this is our avatar. Now, let us paste in the code here, which is quite simple. We are going to read the emoji that we have set in our show text. We are going to get the picture converted to RGB. Now again, we have the same process here. We are creating an image from our array, which is a frame, which is frame 2 here. Now we're going to create an image TK, which is suitable for putting it on our image TK label. We are repeating the same thing here. And we are also configuring the text here and our fonts. We again update the root and call the same function again after 10 milliseconds. So this is going to run indefinitely here. Let's save this and run it. Hopefully it's going to run. Type in Python emoji.py. Okay, let's see if everything is going to run smoothly. Okay, it actually loaded up. There is a little problem. Okay, if you get this type of problem, as I'm getting here, in most cases this means that something didn't get loaded in correctly. So it most certainly has to do something with our emojis not being loaded incorrectly. Okay, this is the problem. We are inside of data, but we should move this to source. So now it should be running, but it was also good that you saw this problem here. So in 99% of cases, this problem is due to not importing something correctly. So as you can see, this is working here. This is some image I have recorded earlier. Since we have those 10 milliseconds and we need to run the data for a certain amount of time, this moves a little bit slower. But you can fast forward to certain positions or use your camera in live mode and you will see that it works quite well actually. So for example, it got that we are surprised here, which also looks a little bit fearful, so yeah, it's hard to distinguish that correctly. Our model works fine. In this case, it was a bit too fearful, but it depends a lot, I noticed, on the angle that you're filming from. Try it with your web camera. For example, the angry one didn't get really located in this case because it really depends from what angle the camera is coming. Like I noticed that if the camera is a bit above your head, and you're pointing from up to bottom, it works better, but it mostly comes down to the data that we have used here. For example, as you can see in those images, there are also certain angles that have been used, so maybe another data set would be a bit better for that. But it really depends, like try it on your web camera from certain angles, try to look surprised, try to look fearful and angry. So and tell me in your comments how it worked out for you. Did you have any problems? Always, if you encounter any problems, if something doesn't work, always leave comments and we'll try to fix it as soon as possible. So I really hope you learned a lot in this and that you enjoy this one. It was a bit different and I'm sorry for not really typing out everything manually, but certain parts become too complex for that and it would take too much time. So I tried to explain everything from a higher overview, from a higher level, so that you could work with this and deepen your knowledge in the certain areas that interest you the most. So thank you for watching. Take a little break, maybe recap things, reread something, go into the documentation, and I see you in the next project. Okay, this was a really interesting topic we have covered here and a lot different than the other topics we are covering. So, of course, neural networks and machine learning is quite a broad topic and we can't explain it fully in 2 hours. Only explaining one module like TensorFlow could take up to 10 hours just going into the basics. But you should have an understanding where to look for new things and have an understanding how those things are created, trained and used, which can be really useful for your further development. So what are the topics that we have covered? We have covered deep neural networks using TensorFlow. We have covered object-oriented programming a little bit, like we cover in most of our projects. Machine learning, we have done a lot with machine learning. We have seen how we can create those layers. We have seen how we can train a model, how we can use it, and so on and so forth. And we have used a lot of other Python modules and principles like Keras, OpenCV, threading, TkInter, and so on. So you should have a really broad understanding of the topics since we have covered a lot of ground here. I hope you found this tutorial quite interesting, and we had to do this one in a bit different way. I was pasting in code since I thought that would be the easiest way for you to understand what we're talking about. So take a little break, look through what we have done here, maybe ask some questions, try to change something, try to break something, and I'll see you in the next project.